Do you want to write powerful queries without complex backend logic? Then you need to understand the aggregation in MongoDB in detail. So, hello everyone, and welcome back to my channel. So, we are going to continue our MongoDB playlist, and in this video, we are going to understand the aggregation from very basics. So, in this video, we are going to cover only two operators which is being used in the aggregation, the match and the project. So I request you to please watch the video till the end to get the clear understanding on the aggregation basics with the hands-on exercises. So without any delay, let's start our video. Now let us understand this concept of aggregation, which is very much important in MongoDB. So let us understand. So aggregation is a technique in the MongoDB which is used to process the multiple documents based upon our query, and we would like to compute our result, and then we will return it as the query result. So sometimes what happens is uh, there are some of the use case where our simple query doesn't work. Like we need to find the sum of all the particular field value based upon the query. So we cannot perform it in our query like we generally use the find and the find one. So if you haven't watched that, so you can go through that and you can come to this aggregation topic. So let's say I want to find the sum of all the fees of the courses where title begins with Java, or you can find average of course completion percentage, and you can, yeah, again you can find average of all courses where category is Java, Spring Boot. So these are some of the use case where our simple query will not work at all. So that's why we need aggregation. So first we are querying our data, and then we will process it, and then we will return our result. So whatever we are doing, like some we are finding average, we are finding average again. So this will not physically save our result. So it will happen only once I query it. So this will be the aggregation. So we can understand the concept of aggregation with the analogy of SQL. With this function, like we have the sum, we have the count, we have the average, and we have the group by. So these are all the functions provided by the SQL to in order to perform computation on the particular column value like we have in the table. So let us consider an example. So we have this employee table, and we have the following columns, like we have EMPID, name, designation, department, and the salary. So let us perform some of the queries here. Let's say I want to sum all the salaries of all the employees within this table where department is equal to sales. So we will have select the sum of EMP underscore salary where from employees table where EMP underscore department is equal to sales. Okay. And let's say we want to fetch EMP underscore name and EMP underscore designation from the employees table. So let's say select emp underscore name, emp underscore designation from employees. So this is pretty simple query. So this is not an execution part. And let's say I want to count all the employee IDs where salary is greater than 10,000 and EMP department is equal to cloud. Okay. So let's say we want to select count of EMP ID from employees where EMP underscore salary is greater than 10,000 and EMP underscore department is equal to cloud. So this will return all the count of the employees where salary is greater than 10,000 and department is equal to cloud. And we can have this average. Let's say I want to select the average. Let me correct it again. So let's say I want to find all the average of the EMP underscore salary from employee table where designation is equal to engineer and department is equal to software. So it will calculate the average of employee salary of all the employees within the employee where designation is engineer and department is equal to software. So this is some of the queries which I have written in the SQL. So all the queries which I have written will be very much similar in the MongoDB, but the syntax will be different and the process for writing down all the queries will be different. So I hope you understand the concept of aggregation with the help of SQL. And we will be doing one demo to understand the aggregation practically. So I have created one database for you. So it is the aggregation underscore DB, and we will have the sample collection. So I have created the sample collection for you, and let us perform the find method. So within the collection, I have created 5 documents for you, and each document contains the customer, product, price, and the quantity. So let's say I want to find the particular sum of all the prices available in the collection. So using the find method, we cannot do it. So that's why we have the aggregation. So let us see aggregation in action. So we will have db.sample and then we will have this method aggregate. Now for now, we need to provide the array of all of the nested documents. So our first nested document will be is underscore group. And for now, you don't need to understand the syntax. We will understand the syntax and each operator in detail in the upcoming videos that will be covering aggregation in depth. So we have this underscore group, and for now underscore ID will be null, and the total price will be the sum of all the price. So to refer the particular field, we will use the string and then $price. And if I execute this statement, I will be able to fetch all the sum of all the prices available in this collection. So this is the sample of the aggregation. And now let us understand more concepts related to aggregation. So let us understand this concept of pipeline, which is pretty much important in our aggregation queries. So behind the aggregation, MongoDB uses the concept of aggregation of pipelines. So if you understand the word pipeline, it means the connection of the pipes like we see in our daily life. So, so this is our pipe one. So let us take an analogy, and this is our pipe two, and this is our pipe three. So each of the pipe is connected with each other, and the flow is continuing without any issue. So if any of the pipe is broken, let's say this pipe is broken, then our execution flow will be interrupted and this pipeline will not be working properly. In similar manner, MongoDB have the stages, and the stages can be n number of times. So if you see this syntax, so it is db.collection dot aggregate, and we have n number of stages available in this aggregate method. So each of them is connecting to each other to create a pipeline, and based upon that we are processing our documents accordingly. So the ordering of the stage is pretty much important whenever we create a pipeline of aggregation. So the each stage could be the filtering of the documents and modifying or projecting the documents, which means we are selecting uh, very few fields available in the documents, not all the fields, and then we are grouping our documents, or we can calculate the values like we did in our previous example. We have performed the sum of all the prices available in the collection. So this is how you create a pipeline in the aggregation queries. And let us take an example to understand this pipeline more properly. So here is our collection before the aggregation. And once we execute our aggregation query, first we filter out all the documents based upon our condition. And then we group the field values like we did for the sum, or we can do it for the average. And then we return the result as the aggregation query result. And let's say we have another use case. So we have this collection and we have the filter. First we filter out all the documents based upon our condition, and we projected our fields. So whatever the fields we want in our result, we projected it, and then we return the result after executing the query. So this is how the pipeline works in action. And let us understand some of the operators available in the aggregation. So in this video, we are going to understand only two operators, the match and the project. Now let us understand this match operator in detail. So it is used to filter the documents in the aggregation pipeline. So whenever we create our pipeline for the aggregation, this match operator ensures that your data will be filtered according to the conditions which you have specified. So let us see some examples to understand this match operator. So we have this collection products, and then we are using this aggregate method. Within the aggregate method, we need to pass an array of stages, and first it contains only one stage to filter out all the documents. So here we place our match operator in the first place, and then this is the whole condition which we have applied. So the first query says that we need to filter out all the products available in this product collection where price should be greater than 100. Let's say the currency of the price is dollars. So the price should be greater than 100. Only then it will match all the documents for the aggregation, and it will be processed in the upcoming stages. So here we only have one stage, and let us understand the second example. So we have the product collection, and once we execute this aggregate, it will match all those documents where quantity is greater than equal to 3. So this is GT operator, which is greater than equal to. So this is the basic syntax for the match operator, and we have seen some examples. And for note that if we are applying conditions in the aggregation pipeline, then this match operator should be placed in the early stages of the aggregation pipeline. Or you can say that you should be placing this match operator in the first stage of the aggregation pipeline. Sounds good? And let us understand this underscore project operator. So this project operator is used to project, or you can say select field specified in the stage of aggregation pipeline. So it is pretty much similar to the projection which we did in our find or find one query. So if you haven't watched that video, you can watch it. So let us understand the syntax. So first we will have the db.products, then we will aggregate, and then we will have this underscore project, and what fields we require. Let's say I want the name of the field, I want the name, I want the price, I want price, and I don't want underscore id for now. So I'm closing it. So this is the sample query for the project. So what it is saying that I need only name, and if you want to show this particular field in your aggregation result, then you should be mentioning one. And if you don't want to mention the particular field in the aggregation result, then we need to use this value 0. So the result will be returning as, so here we will be having our name and then the price of this particular product. So the value could be anything. So this is how the project query works, and let us understand another example. So db.products dot aggregate. Again we use this array, and we will have the product project operator again. Let's say I want to use this name. I want name here, so name will be 1, and the total price will be used as, yeah, price. I want to score id is 0. I want quantity, so this is qty, and we will be closing this. So yeah, this is the sample query for your project stage. So if I use this aggregation query, I will be returning as name, so the name of the product, and the total price. I won't be showing this underscore id, and the quantity. So we can use it for the alias of the fields which we have available in our document. So what we have done is, so we'll be returning the name, and instead of returning the price field, we are renaming as the total price, and for qty we are going to replace it with the quantity. So this is the sample result of this aggregation query. Now we can combine this match operator and the project operator together in order to create an aggregation pipeline. So let us take a scenario. So we need to find all those products where price is greater than $100, and we need to show only name and the price. and underscore ID should not be in the result. So let us write our aggregation pipeline. So it is db dot products. So the collection will be our products, and then we will have this aggregate, and we will have the array first. So first we will have this match stage. So we'll be matching all those products where price is greater than $100. So first, second, third. So this is our first stage, and then we will be using this project operator. And first, we will be returning the name. So name will be one. Price we will be also returning. So price will also be one, and we will not return underscore ID. So underscore ID will be zero. So we are closing like this. We are closing the array, and so this is our complete aggregation pipeline. So it contains two stages. First, it is having the match stage, which will be matching our documents as per our condition. And then this is our project stage, where we are projecting only limited fields available in our document. So I hope you understand how to combine these operators together. And let us go to our MongoDB Compass so that we can perform some hands-on exercises based on the match and the project operator. So we are in our Mongo shell, and I have created one collection for you. So it is orders collection. And first we will see all the documents available in this collection. So this is the sample collection, and each document contains customer, product, category, price, and quantity. Now let me clear the screen, and we will perform our first aggregation exercise. So we are going to filter all those orders where price is greater than $100, and we are displaying only fields which is customer, product, and the price. So it is db.orders, then aggregate. First we will use our match operator. So before that we need to pass an array, and we will use our match operator. And then we are going to use this price, and again nested document, and it is gt for greater than 100. So the price should be greater than 100. And then we will be using this project, and what we need to show is name and product and then price. Now if I execute this, so I am able to return all those documents where price is greater than 100, and I am returning the product, price, and underscore ID. So underscore ID will be default in our aggregation result. Now let me clear the screen. So our second exercise will be, we need to show the product name, and along with the product name we need to show its total amount. So the total amount will be product of the price and the quantity. So we will use this db.orders, and then we will use this aggregate, and first we will use this project operator, and within the project we need to show the name of the product. So the name of the product will be one. So this will be visible in our aggregation result, and then the total amount, and then we will use this multiply for multiplication purpose, and then we need to mention the fields which we need to use. So first is the price, and the second is the quantity. So if I execute this, I am able to return the result with the modified document. So here we are returning the name of the product, and it is the total amount, which is the multiplication of the price and the quantity. Now let me clear the screen, And let us perform the third exercise. And first, we need to filter out all the product where category is electronics, and we will be displaying the customer name, product, category, and the price. So it is db.orders. Then we will be aggregate. We will pass two stages for now. So it is first one is the match stage. So we'll be matching. So matching the category where category is electronics, and then we will project our result. So project, what we need to project is customer, then price, then product, then category. And for now, we are not going to show this underscore ID. So we are mentioning it as 0. So if I execute this, I am able to return the customer, product, category, and the price, where category is electronics. Now let me clear the screen and let us do the fourth exercise. So in this, we need to display a product, price, and the quantity, and we are going to create a new field in the aggregation result as the order value, where order value is the multiplication of price and the quantity. So it is db.orders. Then we will use this aggregate, and we will use this project operator. And first we need to show the product as 1, price as 1, quantity as 1, and then the order value. Order value is nothing but the multiplication. So we will use this multiply operator and multiplication of two fields. So we will have the price and we will have the quantity. So if I execute, I am able to return the product, the individual price of that product, the quantity, and the order value. So the order value is the multiplication of price and the quantity. So let me clear the screen and let us do the final exercise of our aggregation. So we will be returning all those orders where quantity is greater than equal to 2, and we will be displaying the customer, product, and the quantity. So db.orders, then aggregate, and first we will match all those orders where quantity is greater than equal to 2, and then we will be using this project. So we are displaying only customer, product, and the price. So for now we are displaying the quantity, not the price, and we are not going to display underscore id, so I am mentioning it as 0. So if I execute, so I am able to return the customer, the product, and the quantity. So this is our end of the exercise for the aggregation. So let us summarize what we have discussed in this video. First, we discussed that what is aggregation, and we understood the aggregation with the help of SQL queries. We understood that why aggregation is important for the MongoDB queries, and we understood the concept of pipelines, and we have two operators explained. First is the match operator for filtering out your queries, and the project operator for reshaping your documents. And at the end, we had the hands-on exercises within the MongoDB shell. So if you have any doubts or you want to know more on this aggregation, then feel free to comment in the comment section. If you are able to understand this aggregation topic, please give a like to this video and share it among your friends so that they can get a clear understanding on the aggregation. So this is the end of the video and I will see you in the next one.